Hi guys, I'm going to talk to you about dimensional analysis. So dimensional analysis is basically just a fancy way of saying that when I do conversions, my units need to cancel. So if I wanted to do how many inches are in a foot, let's say inches in, I don't know, 2.5 feet. That means I would go, okay, I start with 2.5 feet. 1 foot is 12 inches. My feet cancel, and then I would just multiply straight across and go 2.5 times 12 is 30. I mean, that's like a really basic way to look at it. I do have another video posted in the slides that goes through this, but I'm just going to talk about a couple of problems from your assignment because I know it's a little weird right now how we're doing school. One of the things to keep in mind is that when you're doing this assignment, you're going to do it on a separate sheet of paper. You're going to take a picture of your assignment and upload it to Canvas under the assignment name. So we're going to look at number 1 and number 6. And I picked 2 different problems. I wanted to do a metric conversion, which is number 1, and a time conversion or something that's not using your metric prefixes. So the first one you have is 35 milliliters equals blank deciliters. Well, milli and deci are both metric prefixes. And in order to convert from milliliters to deciliters, I'm going to do milliliters to liters to deciliters. And I know that 1,000 milliliters is 1 liter. And I know that 10 deciliters is 1 liter. Okay, so I'm going to set it up where my 35 milliliters is what I'm starting with. And I'm going to do milliliters to liters. So milliliters is on top, milliliters is on bottom, liters on top, and then liters on top, liters on bottom to deciliters. And then I'm going to fill in my numbers. So 1,000 milliliters is 1 liter, and 1 liter is 10 deciliters. So I multiply straight across the top. So first I'm going to cancel my units, and then I'll multiply straight across the top. So 35 times 1 times 10 is 350, divided by 1,000 is going to get me 0.35 deciliters. Now, you probably are wondering, why are we doing it this way? Wouldn't it be easier just to divide or multiply the normal way? It would be probably, but we're going to start doing it this way because we're going to do more advanced chemistry stuff later, and I want you to be able to solve your problems this way. So just, humor me and do it with me. All right, so let's go to the next one. This next one, we're doing years to hours. So years to hours, and I'm told on my paper that 1 year is 365 days. So basically what I'm going to do is I'm going to go years to days to hours is how I'm going to do this. Because I know that 1 year is 365 days and 24 hours is 1 day. So I'm going to put that into a table here again. So I'm starting with 1.3 years. Years on top, and I'm going to days. And then days are on top, so days are on bottom, and I'm going to go to hours. So 1 year is 365 days. 1 day is 24 hours. This one I am going to use my calculator really quick. I have 1.3 times 365 times 24. I'm going to get this big number, and that number is 11,388 hours. Well, I'm still having to take into play significant figures. So I'm starting with 2 significant figures here. So this is just going to become 11,000 hours. And the reason why we didn't have to worry about this on the last problem is when we did a metric conversion, your significant figures aren't going to change at all. I'm only multiplying or dividing by 10. I just have to make sure if I'm supposed to include zeros or not. So to double check my work again, I cancel my units. Everything cancels out. I'm left with hours, which is what I was solving for. So try this out. Do it on your paper. If you have questions, let me know. I'm here to help you. I'll talk to you guys later. Bye.